So, hi everyone, my name is Romain Hugo. I'm working at Evolving Web, and I'm today going to talk about how to build a scalable data-driven application. So I know on the schedule it's written like it's going to be around React. Actually, it's not specific to any framework. So we can work with React, we can work with like any framework, JavaScript, TypeScript, PHP, whatever. Today I'm going to speak mainly about like architecture and how to think this kind of app and how to do and how to process those kind of data. So to present, I'm going to rely on the actual case we currently have at Evolving Web. So first I'm going to present you like the context. So it's about like a company or project that's named GRID, which stands for Global Repository of Income Dynamics. So it's a project that provides an open access international database, so a lot of economics data about income and income inequality and dynamics across the world. So it's currently across 26 countries, but there's a lot more to come, and they still like make this database growing like each year. So there's granular data, so it's by date, by age, by gender, and it's built by an international team of economists led by three important economists that are currently in the US at like prestigious university like Princeton and Stanford. So that's for the client. They currently only have like an application, which is a download application. You can download the data in CSV files. So we were like asked to build a new application, a visualization data application. So the main goal was to provide like a way to display those data with charts. So with like different kind of charts, like a map chart, a line chart, bar chart, and ensure of course clear and intuitive navigation and UI UX and high performance for sure, and to maintain this neutral and non-biased data presentation. So that's for the context, that's for the application, what we wanted to do. So let's see what the main challenge was. So when we first had this data in the end, we encountered like a mathematical problem. Like we were facing more than 300 statistics, so more than 300 data statistics across 26 countries, three gender options. The three gender options are female, male, and like an aggregated like gender, all gender, and 5 age group, and for some countries more than 50 years of data. And so we were facing like potentially 5 million of states or Ks or in the US, so we had to think about a system that would handle like automatically. So, for example, for this kind of project, we would have like this typical timeline. So first, we would like to have this discovery phase of what can we do with those statistics. So first, we would maybe build like a MVP or a proof of concept. So the pitch will be let's build something quick. So we will like an application that can handle maybe 10 statistics. So some hard-coded logic to build it faster, and everyone will be happy, and like code will be messy, but yeah, we'll refactor later. Then come the phase 2, the goals. The pitch will be like, let's add 50 more. And so maybe we have to build fast. Also, we have like maybe a couple of months or 3 or 4 months, and we will copy paste some code everywhere. Like we will have like a lot of code duplication, major bugs appear like for the first time, and then the dev team will like ask themselves like, should we refactor? And the answer will often be like, no, we don't have time. We have like a deadline for that. And then the phase 2 will be like the issue. That's when the dev team gonna hit this wall and like add those 240 remaining statistics. And oh, the client wants new features too. And then the dev team will be like, we can let like team velocity will drop every changing in the code would break everything, and we would end up with like the decision like we need to rebuild this. We don't have the choice. We can't use what we already did. We need to start over and to build things differently. So came the question like how to build a fully dynamic application for this complex set of data. And we like kind of have a list of what we want and what we don't want. For example, we want for sure maintainability because it's a project that's going to last for years and should last for years. We want scalability because we would like to add more statistics, to add more countries to the datasets. Testability for sure, usability, performance, exactly, because we have like a lot of data. We don't want like it to make seconds to load the data. So that's what we want, and of course we don't, and we absolutely need to avoid tightly coupled code duplication, performance bottleneck, and rigid structure. So with the challenge, we have like the solution for that. We thought about the solution, and we asked themselves, what if those statistics could describe themselves? So instead of like, what if we stop telling the app what to do and let the data tell the app what it needs? So, for example, don't write code for each statistics. Write like something more like build for the ensemble, not one statistic at a time. Think in terms of patterns. Build a flexible and modular structure that grow. Think about the scalability from the start. As it's a project that's gonna last for years, you need to think that first and to build like a solid structure for that. So we came with like those 3 pillars, which are actually more like steps. So first we will have like what are we wanting to visualize. So we will have like the statistics themselves. So we will have like a data file. So we will have like a file that where every statistic is gonna describe themselves. So for example, I'm a shirt of 10% statistics. That's my name. I need that. I need like those X and Y axis. I need those label. I need the scale, stuff like that. So let the data describe themselves. Then we would have the second step, which is like the smart system. Like, for example, oh, you're the shared 10% statistics, you have these properties, so this is the time series statistics. It needs a map and these controls. And then we have the third step, the display, the user interface, and it will consume what the second step, what the smart system will give him. And like, here's your controls, here's the map chart, and it will render those UI parts. So those 3 pillars, if I speak like more of in a technical way, become those pillars. So first we have the configuration. So it's a config first design. So pure data, no logic. Like really like just a list of properties for each statistics. We need to know like everything. Like the system needs to know everything about those statistics to then use those self-describing objects. So it's going to be like classes. So we have like a hierarchy. So it's going to be like inheritance. Going to be so stuff like that. So it's going to be like polymorphism. So that's the polymorphism that's going to handle the variation. And then, so the third step, the dynamic queue will use those classes. So it's going to use like one class per statistics, and from there it's going to use like a factory pattern to have the right class instance, to have like a constant implementation and instantiation of all of the properties that makes the statistics we want to visualize. So our the flow will be first the configuration with for example it's going to be a JSON data. Then the classes with the factory, so we would register every classes and to get the right instance. And with the statistics instance, we're gonna have the right information to render the UI and the charts. So let's deep dive into those 3 pillars or steps. So first, part one, we have the configuration. So configuration, that's just data. So think of it as a profile card. Like on this profile card, you're gonna have all the properties you need for the every statistic. So for example, we have an ID for sheet. Like we need an ID to identify which statistic it is. So then we will have like a name, the personality. So for example, these statistics like 90-10 percentile difference is what we can name like a time series statistic, because the data is shown across like years, and so we need to know how it's gonna like be like on the chart. For example, the time series, the x-axis is years. So, but the personality, that's what we can like convert in code like as a class. So we're gonna have like the time series is gonna be the class, and that's the class that's gonna be used by the system to then render and to have all the parameters, and to give all the parameters, the UI is gonna need to render the controls and the charts. And then we can have like a lot of other properties like the scale, the y-axis, the x-axis, and there's a lot of more, but that's just an example. And the configuration, just data, once again, no logic here. So, for example, that's how like our JSON config file will look like. Gonna be just a list of objects, one JSON object per statistics. So we will end up with like currently more than 300 statistics in the configuration. Currently we have, I don't know exactly, but a little more than 10 different personalities, so 10 different classes. And what each statistics is one simple config object. Next, we'll have the second part, which is like the classes. So the classes are there to provide behavior. So in our hierarchy, one at the top is the interface. Though the interface acts as a contract. So the interface is going to list all the methods, all the things that the classes will need to provide. So it's going to have, it's act like a contract, as a contract that every classes need to follow. Like it's a list of methods they need to implement. So the polymorphism can work well. So then we would have like the base class, so the statistic base class. So this first class is gonna implement all of the statistic interface method. It's gonna provide all of them, as we have like a strong base class for the other one that's gonna come below it. So the base class basically is gonna define all the default behavior, like for everything. And then we're gonna have like inheritance for all of the specific statistics like time series, density, mobility, and like we can have also like inheritance in other levels. There's no like limit for that. So this way each class can behave differently. So first we have the contract. So the contract is just interface. So the interface. So we're gonna list every method we're gonna need to make this app work. So all statistics must provide this same list of methods. So yeah, so that's how polymorphism works. Then the base class. So that's an example of a base class. So we're gonna like create all of the methods. So for example, if we look at the get view mode, so we first gonna read the config, what we have in the config, and if we don't have anything, we're gonna add like a default value. So for example, this default value is the available view modes for by default is gonna be map, line, and bar. So the three view modes we need. So yeah, it's read first from the config file and provide default value, and for example, for the first one, the ID and the name, we can provide a default value as it's going to be like unique for every statistics. But for the other one, we can add like those default values, and it's going to work the same for the other class below. So, for example, the time series statistics is going to extend the base class, and there you can override methods. So, for example, for the second one, for the density statistic, we wanted like the density statistics to have by default only the line view model. So that's how we can like add different behavior for defined list of statistics. So that's the polymorphism. That's the same question, but it can bring different answer depending on which class is instantiated. So that's for the second part. And then the third part is about like the factory. So the factory is going to create everything. So when we want to display like statistics, we're going to ask the factory to give the UI like an instance of the right class to use to build the app and build the control and the chart. So in the factory, how it's works, we're going to first have the registration. So we're going to register every classes we're going to need for those statistics. So that happens once. So we have like a catalog of classes, and then for the production, so it's gonna read the config. So if we ask for a specific statistics, it's gonna read the config, find the class name. So that's what I show you in the config part, and then create an instance of the right class and return this ready to use object to the application. And as all of those cases have the same methods, it's going to be the same implementation for every statistics. So we don't have to like code specific stuff for statistics. The specific code is going to be in those classes. It's not going to be later in the rendering of the UI and the control and the charts. So then we have like the payoff. So that's how the UI is auto-generated. So first the user selects a statistic, so let's say share flows compile. Then the app creates a class instance, and the class then generates its control. So for example, in the classes we have like those, that's an example, but those two methods to render a list of control. So for example, in our layout, we have like a sidebar and a top navigation control. So it's gonna, for this example, we're gonna have on the sidebar the country selector, and on the top now we're gonna have the statistic dropdown, gender, and age dropdown. So that's how it's built, and so we use React, but it's gonna work the same for every framework. We have like components everywhere, and we have missing components. And for example, we have like a sidebar component that's going to read this method to know which control they should render. And same for the top nav control. It's going to be, oh, I need to render the statistic, the gender, and the age dropdown, and it's going to rely on these cases to build the UI. And so the UI renders automatically thanks to that. So there is no like hard-coded dropdowns, and the class define everything. Everything comes from the class that pilots what's going to be in this UI. So let's speak about some benefits or some real-world benefits about that. So for example, let's say tomorrow I need to add 10 new statistics to our application. So the traditional approach, we need to like write new components, add conditional edge, handle some edge cases, if that's the case, and we will have to test all the combinations. So this can take like hours or days. With this approach, we just have to add 10 config objects in the config file, so 10 new config objects. So we have to give the application was described these statistics, every properties. But then, if there's no like new behavior needed, we just will have to run the automated tested and the test, and then it's done. If we have like new behaviors, new chart, new view mode to add, we just add like a new class maybe that's gonna extend the hierarchy we already have, and in this new class you're just gonna have to define the method you want to override, and then if you need like a new type of charts, you're just gonna need like to build this chart component, and it's gonna be used as the existing one. So and the most important part that it's not gonna impact what's already existing in the application. So that wouldn't break anything, and that wouldn't like make the app unusable. Another benefit will, if we speak about code metrics, the traditional approach would necessitate a lot of coding. That's some example numbers, and those are not actual for both sides, but that just to illustrate what I mean there. Our approach is going to be like a lot of config file, a lot of lines in the config file as we want to describe the data as precisely as we want. But then in the logic, in the logic code, we will have like way less code than in the traditional approach. I evaluate that at 90% reduction of logic code, but that's important, especially for a developer, for dev team to maintain. And
I'm fascinated by these numbers, and I noticed it says estimated, and I'm always skeptical about 90% reduction or performance improvement. I do know that before working on this project, you worked for us for climatedata.ca, and you didn't do the architecture for that project, you joined afterwards. Would you say that the approach for that project was more like the one on the left, and the lines of code was
for climate data?
Yeah.
No, it's more on the right. For
okay.
Data. We use the same logic. We have like a configuration, and then we have like some classes. So it was quite similar. We have like some climate data. There's like a WordPress instance where we store some data in there. So the data was not like centralized in the config file, but more in the config file and in WordPress variables. So that's the main difference.
So how do you know it's a 90% speed up? I mean, it's very unlikely.
Like it's estimated, like it could be even more. For 300 statistics, it could be like massive. Like it's just like like some numbers to like illustrate that we will have like a lot of less code, and so less code to maintain, less code where we can have issue, less code. So less code is better because it's better to maintain. It's way easier to maintain. So for example, some maintainability is real. So let's say we have like a bug for the time series visualization. So time series is about like 50 or 60, 70, I don't know, statistics. So that's a lot of statistics. But if we have like a bug for this time series statistics, we will have to fill that in one class or in one component if it's the chart component, for example, in the line chart component. So as the code is like reused and centralized, it's way less maintainability to do. So that's a huge win in terms of time, cost, anything. So if we need also a new type of chart, that's why I said earlier, we just need to create a new chart component and to make it like to use it in our class. Same thing for a new feature or a new control. Same thing. We create this control if it's a new kind of control, and then we call it from the get control, the method, or whatever it's named in the class. So yeah, so also it's scalability proof. So because for now we just have 300 statistics for some 26 countries, but with this structure we could easily scale to 500 or 1,000, and more countries to like. We know that that's what the clients intend. Like they want to add like each year some statistics. They want to add like some country data. They're still like collecting data everywhere. So that's their main like focus. And so we could do that easily without any architectural changes. Last benefit, for example, the configuration driven, it's AI friendly. I think everyone knows that AI is quite trendy those days. Like this kind of architecture is very great for AI because it's repetitive patterns. AI loves repetitive patterns. It's declarative structure, so there are clear rules. We are using TypeScript in our example because I'm using React, but TypeScript is nice because it catches error. And most importantly, there's many examples like already listed in the code, and we know that AI works the best when the context is like, the more we have context, the better the AI is going to be. So we can easily like, if we like to add like component to have like chart types to add control, we could easily vibe coding those, I guess. It's gonna like scan the code, it's gonna see how it's working. You can add like a context file if you want to make it better, but we would like really gain some, like have some time gain in those kind of like, in this kind of application if we would like to write code, and that's easily something we can do. So I'm going to end with those lessons and takeaways. So when should we use this kind of architecture? So for sure it's a good thing when we have like data-driven application. So when we have like many similar entities like we do, when so we have like a lot of statistics, like hundreds of statistics, it's a lot of them, and that's perfect architecture for that. It's good for horizontal scale. It's good for repetitive patterns and for long-term maintenance. And for sure, it's going to be like overkill for something simple. When we have like a few versions, if for example we would have like 10 statistics and the client didn't like wanted to add more in the future, we wouldn't have need this kind of stuff because it's like it took longer to create, like to start with the project, because you have to create this whole structure, and it would be like overkill for like a simple application for a proof of concept, MVP, or prototypes, whatever. So yeah, yeah, there's more upfront work, and but it pays off at scale. And finally, the key principles. So it's configuration first. So let data drive the behavior. So like the important part, like describe the data, give all the information we need, and it's gonna like handle like automatically later. Polymorphism over conditional. So we use classes instead of if else. Interface dealing, define contracts, then implements. It's important to have contract as we have create like boundaries, like the AI, the UI know, the application know what it needs and what it has, and it's the same for every statistics. And then the factory pattern for consistency, so central point of registration. So everything like is registered in the factory, so the application know exactly what to use and when to use it. So I wanted to maybe finish with like a short demo. So that's the actual product. The current product, it's not yet over, but it's almost done. It's going to be launched like in a few weeks or months, but that's how it looks. We have like so this sidebar and the top control over there, and then we have the charts in the main part of the application. So for example, that's a world map chart. You can there change the statistics. There you have the years below, and you just can drag and drop it. If I go to there, you're gonna have the line chart. So for example, we can plug together United States and Canada data. So that's how it's gonna look. We can add some statistics. So let's say I want this one, and so we're gonna have like 4 series over there, and we have the map chart that's gonna look like that. So yeah, that's pretty much how the application works. So we have like a lot of statistics, but those are divided into income concepts, which are groups, and we have 2 different what we call datasets, but it's like 2 big groups, we say. Like first is the inequality data, and the other one is the dynamics. So yeah, that's it for me. Do you have any questions? No. Yeah.
You mentioned that this was AI friendly, and from what I overheard, you used AI in this presentation. Sorry, in developing some of this stuff. Can you speak to where it helped? And
Yeah.
what you did?
Well, the first part where we used AI was for the discovery phase. Like when I started working on this project, it was like, here we have 300 statistics. Let's do something that we can visualize also, and we didn't even know what those statistics were. So we had to use AI to understand how it's gonna be used, what it means, and how it can be organized. And then yeah, I use also AI. I use Cloud Code for building some part of the application to like to build the charts, to build the UI actually, the dynamic part that's going to use those classes. But yeah, it was very useful.